Hi everybody. In this video we are going to talk about projector lamps. I have a nice selection here of projector lamps that should cover all of the major manufacturers that you may see if you're buying a new projector lamp for your projector, or if you're looking to repair or replace a lamp in a projector for somebody. I'm going to go over the parts of the lamp and the bulb, as well as what those parts do and which one's important and what you should look for, all that fun stuff. So just to kind of go over what we see here, these are some OEMs and some aftermarket, as well as some original aftermarket, and I'll explain what that means in a moment. First, let's go over the originals. This is a Panasonic ETL8060W lamp, or this one says ETL8060A because it's a replacement. A means aftermarket, meaning it was not the one shipped inside the projector. It's from Panasonic, but I assume for their inventory purposes they use the part number A. If you see ETL8060AW, W means twin pack or 2 lamps in a pack. Most of the projectors that use these use at least 2 lamps. Some even use as many as 4, and usually they just use 1. So this is a used one. I have the timer board removed at the moment because this is really just a sample. Usually there's a small PCB here that records the time. Oh, here it is. I know I had it close by. So this is usually mounted here, 2 screws. This connects to the projector and records the hours that the lamp runs for. This is also a Panasonic. This is an aftermarket with a Phoenix brand bulb inside. Phoenix is a company that makes replacement lamps as well as original lamps. That's similar to this bulb. This is made by Ushio. Doesn't have it on here. Usually it's on the reflector, but I can tell by the part number that it's an Ushio. This is actually a DC direct current, not an AC Ushio bulb. We'll get to why that's important. Then we have an Osram, there we are, Osram PVIP bulb. This is also an aftermarket lamp. It's not one that would come inside the projector, but it's a really nice replacement lamp. It's as good as the one that you would buy from, I think this is a smart board, 2015, I can't remember. I'm pretty sure this is a smart board lamp. Then we just have a bare bulb here. This is a Philips bare bulb, 300 watt. This number here, this first number is actually the part number. In fact, we'll go over these one by one, but let me just give you the first overview. Then we have this one. This is an Epson original. You can see by the sticker there. The bulb inside here is not made by Epson. Panasonic is the only company who actually makes their own bulbs. Epson bulbs are made by a company called Iwasaki Eye out of Japan. They make the bulb, and then Epson puts it inside the housing and then sticks it in the projector. Osram makes a replacement for these, which is quite good, and we'll get to that in a moment. And then I have this one here. This, I'm pretty sure, is an old Osram HBO, I think. I just wanted to show you guys what an arc tube looks like by itself. This is a DC arc tube, direct current. Reason you can tell, well, there's a couple ways you can tell. One way is they have a plus and a minus marked on the, or just a plus in this case, marked on one end. But you can also tell by the size of the arc points in the middle. See if I have something dark I can put behind this to make it a little easier to see. Yeah, we'll try this old battery. You can kind of see how that side's a lot bigger than that side. The arc which is just a sustained controlled spark, jumps in between these 2 points, excites the gas inside, and then gives us our light. This is not usually used in a projector lamp. Usually these are for stage lighting or something along those lines. It's kind of neat. I like the holder they keep it in. The arc tube itself is under a lot of pressure, so they do this to protect it. So first things first, let's go over the parts of a bulb. I'm going to move this stuff out of the way, and let's start with this Phillips bulb here. There are a couple pieces. We have the reflector, which is this outer portion. It's made out of glass. It has multi-layers. They do a metallic coating on the inside and then another layer of glass to protect that metallic coating. You can see if I scrape on it with a screwdriver, the metallic coating stays in place. On older lamps, or older bulbs rather, I may switch back and forth from saying lamp or bulb, but I mean the same thing. This is an older one. And on some of these, see if this one does it. Yeah, the coating was right on the surface, and over time that coating would start to come off. On really old bulbs, you would see this stuff crack and just literally fall off. And being that it's metal, it would hit some of the electrodes and cause problems. So anyway, back to the Phillips bulb. We have the reflector. This particular reflector is what they call an E21.8. That means it's an elliptical reflector. There's E and P, E for elliptical, P for parabolic. Parabolic's usually used in rear projection TVs. Elliptical is usually used for front projection. That's what you're going to see most commonly. Now the 21.8, I'm not really sure what that means. It has to be some sort of measurement, but I don't know which one. I have this in millimeters, because this is a European. And if I go to 21.8, it puts us, let's see, come on. Yeah, well, that's 21.8. It brings us to the reflector, but not to the edge. And if I measure the depth, I don't know. I don't know what 21.8 is, unless that's the distance to the focal point of this particular design. I'm not really sure what the 21 and 21.8 means, but it does have to do with reflector shape. That I'm positive on. This bulb, for instance, is a 20.8. So 20.8 and 21.8, they're not remotely, I mean, they're close in size, but you'll see. Let me pull this out, and then you can see what I mean about how the reflector numbers don't seem to add up. There's a large TV lamp that's a P23 that's about 4 inches across. So I don't know. I'm sure it has something to do with measurements, but I don't know which measurements that is. So let's pull these off. Now, if I were relamping this, I wouldn't be pulling these off this way, but this is an old lamp purely for demonstration purposes, which is why I tear it apart like an animal. Let's get that out of the way. There we are. Okay, so as I said, this is an E20.8, and this is a 21.8. So it might have something to do with the square outer reflector, or I still think it's something to do with where the center of the arc tube lines up, but I'm not sure. I've been unable to get any confirmation from Osram or Phillips. Maybe one of you watching this can fill me in, let me know. I'd really like to know. So here we are. 20.8, 21.8. They're close. They're very close, but I don't know about 1 millimeter close. But anyway, just know that 21.8 or 20.8, whatever the reflector number is needs to be matched by your replacement bulb, because occasionally you can substitute bulbs. Obviously this one won't work in place of this one. The mounting's different. This one uses screw terminals. This one uses push-on terminals. But there are bulbs that this can substitute. There's an Osram. Let's see, that's a Phillips. Where's the Osram? Oh, I can't find it at the moment. But there is an Osram that looks identical to this one. I will say the end of it sticks out a little further, but it's also a 300 watt 21.8. So anyway, I digress. Let me get back to where I started. On the part number, get my hand, we get this to focus. Here we are. Okay, so the first part is the part number. This is a 317. The full part number is 9281-317-05390. Then we go to here, 300. That's the wattage, 300 watts. 1.3 is the space inside the arc tube in between the two electrodes. It's 1.3 millimeters. I think this is a serial number or a production number. And then we have AM300-250E21.8. AM means aftermarket, meaning that this was sold through an aftermarket channel. Same exact quality as the original. It's just a lamp that was not sold directly to a manufacturer to be sold inside a lamp. It was sold to be put inside a replacement lamp. Then we have the wattage range, 300 to 250. That means this will work on a projector that requires a 250 watt bulb. It'll work on a 250 watt ballast up to 300 watts. And then we have the reflector info here, E21.8. So those are the numbers you need to look for if you need to match up a new bulb. If you want to save a lot of money and you don't really care if it lasts all that long and you want to buy a cheap knockoff, to each their own. I don't like it, but you got to save your money where you got to save your money. These are the specs you need to match up. As long as you do that, you're usually going to be in good shape. After the reflector, we then have the actual working portion, known as an arc tube, or in the industry they are called burners. I don't know why they're called burners, probably because of the way they're manufactured, but they call them burners. So we have the reflector and the burner, and then we have some wires that are connected to the burner and to the screw terminals. In an AC lamp, there is no cathode and anode technically, because it's AC, so there's really no positive and negative. But we do have what we could call a hot and neutral. To start these bulbs up, they need to use a high voltage pulse to get the arc started. In order to direct that pulse, they have this starter coil right here. It's just a single-ended coil wrapped around the tube. And if we look back here in the back, you can see that the wire goes into the back to the rear of the bulb, and then also comes up, trying to keep it focused here, along the side, and then is wrapped around. And then we have the other side of the wire connection here. What this coil does is it helps the electricity, the high voltage inside the burner, jump across that arc. It just kind of helps direct it. Once the arc started, the high voltage starts to lower and the current comes up, and then these will settle out at around 100 to 120 volts at, I don't know, for a 300 watt, say 3-4 amps, maybe between 3 and 4 amps. When it starts, these start anywhere from 5,000 to 20,000 volts, depending on the chemistry of the gases inside the arc tube. This one, I believe, starts around 15,000 volts. I'd have to double check the specs, but the ballast job is to manage that, to use the ignition pulse to get the arc started, and then lower that voltage and bring the current up to keep that sustained arc to get the nice light out of it. Now, a lot of people are confused about where things are made. They see made in China and they start freaking out. Oh no, I don't want Chinese trash, blah, 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 blah. Personally, I've had nothing but good experiences with stuff I've purchased from China. Maybe because I do my research a little bit. But there's nothing wrong with products made in China. If it's made by a real company, in this case Philips, there's going to be a certain level of quality. The confusion comes because at one point, Philips were exclusively made in Belgium. Philips is based out of Belgium. Netherlands? Europe somewhere. I'm going to say Belgium. Or wait, no, I think, we'll go with Belgium. So, at one point, they were made there. And I'm looking to see if this old one here, this is from a projection design. This is a 400 top half of a housing with an old Philips bulb in it. And I'm wondering if this one has the made in Belgium tag on it. Because what will happen is people will buy a new one, they'll look and they'll go, oh no, this one says made in China, it's a knockoff, I don't want a knockoff, I want an original that says made in Belgium, and then it becomes a whole thing when it's really not. They're still kind of made in Belgium. No, this one says made in China too. But around 2012, Philips stopped making the reflectors in Belgium. They still make the burner. As far as I know to this day, this part, in fact, I'm going to take that out. This part is still made in Belgium, as far as I know. But it was in 2012 that they decided that making this part in Belgium was more cost effective to have them shipped over to China and then have the final assembly done in China. So the working portion, the part that does all the heavy lifting, the burner here, this is really the main working part of the lamp. This is still made in Belgium. Then they send, boxes and boxes of these to China. Then in China, they do the final assembly where they, set the burner in place and get it lined up right and add the ceramic in the back that holds it in place, and then they ship them out. And that's why they say made in China on the side, because they are technically made in China. I don't think they can get away with saying assembled in China. But as I said, the important part, the burner, is still made by Philips in Europe. This also goes for Osram. Osram also says made in China. They used to say made in Germany. Well, to this day, the burner inside here is still made in Germany and then shipped in boxes to China, where they are also glued with the ceramic into the reflector for final assembly. And that's why they say made in China. So just because it says made in China, it doesn't mean that it's a substandard product or anything like that. They're quite good. I've compared new old stock lamps to new lamps, and they're totally fine. Oh, actually, here's a great example. This is an old Ushio bulb out of a Runco lamp or BenQ lamp, depending on which projector it was in. This one still says made in Japan on it. This is from probably 2002, if I'm reading the date code right. Maybe a little newer, but it's an old lamp, old bulb. It says made in China. The ones these days say made in China. And of course I don't have one sitting nearby to show you. Oh, wait a minute. Here's an NEC lamp with an Ushio in it, but I don't know if we can see the other side. Well, here, see? Made in China. But the internals, the burner, is still made in Japan, shipped to China, and then assembled. Most companies do that. Actually, Actually, I don't know if Panasonic might even do that. I don't know if they have the assembly location on here. No, these are fully made in Japan. I think Matsushita, the folks who own Panasonic, are the only company to this day who makes their own bulbs. And even they are now starting to sell bulbs in the aftermarket, which is going to be great for all of us consumers. So let's see, get back to here. We have the reflector and the burner covered. Obviously, we have some screw terminals here. These use M3 screws to hold the connectors in place. Sometimes they use push-on connectors, like with the Osram. They have some, small blade type, and they're good as long as the blades are tight. Then we have another company called Phoenix. Phoenix is a lesser-known company based out of China that made OEM bulbs and lamps for InFocus and Duquesne, maybe? No, Proxima. Sorry, I made them for Proxima. And then they started making aftermarket lamps, I don't know, some years ago. And Phoenix is a very, very good company. Not very well known, but they... you've probably used their lamps if you have owned an InFocus or Proxima. And if you have purchased a replacement Panasonic lamp recently, you may have a Phoenix in it. Phoenix was the first aftermarket company that I know of that successfully made a decent replacement bulb for Panasonic. Osram made one. There is a Philips that works in this. This is actually an ETLAF 100 lamp. It's from a bunch of Panasonic projectors, but that's what this is. This is an aftermarket one. I wanted to show you this one because this one's kind of interesting. It should have, I don't think this one has it at the moment, or does it? I can't quite tell. Oh yeah, there it is. These have an air guide flap inside. All lamps have different features depending on what they are. Some are more involved than others. It's a lot of variation. It has this piece in here that flips its position depending on how the projector is positioned. If you have the projector on the ceiling, I'm sorry, not on the ceiling, on a table, it sits like this. If you have it on a ceiling, let's see if I can do this without it falling, it flips over like that. And this is to direct air inside the lamp to keep the burner cool. It's actually a very common failure on projector lamps. If the air is not guided correctly, such as this lamp right here, this is where the air is guided. And if you look, let's set this back in, so hopefully you guys can see it. That hole, it's kind of hard to see, but the hole lines directly up with the tip of the burner. These burners get really hot on the end. This piece right here gets really hot, and a common failure you will see is this wire will burn off the end. And if that wire burns off the end, or if you see kind of a crystallization build up from the glass, 9 times out of 10 you have a clogged lamp fan. The blower fan's not pushing enough air into that hole to cool the tip of the arc tube. So just keep that in mind if you have projector lamps that fail and that tip burns off. Check your lamp fan and also make sure there's nothing obstructing that vent. So back to Phoenix. Phoenix has an interesting part number system. They like to use SHP for their bulb type. In fact, you can kind of see it. There you go. And there's a little Phoenix logo above it. And the part number for this one is a 30A26. This is a newer part numbering scheme. They used to just use SHP and a number for the OEMs, for the original that were shipped with the projector. And then the replacements would have GL or SX and a number. Now they seem to have settled out on this scheme right here, where they have a number, a letter, and then a number. I don't know what those mean yet. They don't seem to relate to wattage. They may just be a catalog number. Still checking into that. But Phoenix makes a lot of DC lamps and AC lamps. As far as I know, Philips and Osram are only making AC lamps these days. And actually, I don't even know if Osram's making new products anymore in the projector lamp world. I think they're just still making all the original ones they were making, but they're not introducing any new ones. I'm trying to pop that out so I can show you the inside, the clip on this. Yeah, let's just cut them. Like I said, these lamps are all scrap. So before anybody freaks out in the comments and starts hammering out, "You're not wearing gloves, you're wrecking the bulbs." Kind of. But we'll address that in a moment too, because you're kind of right. Oh, actually, I'm really glad I took this apart, because now we can really see how the cooling is enhanced by Phoenix's interesting design. All right. So at the tip of this burner, you can see they have a huge piece of metal affixed to the end with some ceramic glue. And then that side wire goes there, and then the back wire goes there. They are not using a starter coil here. Probably doesn't need one, depending on the gas mix inside and a few other things. That coil isn't always needed. When I say starter coil, that right there is what I'm referring to. So they make sure the air is being blown across that, and that piece of metal there acts as a heat sink and keeps the tip of the bulb cool. And for the heck of it, let me show you guys how these will start. I actually have a little box I made. It's a low current, high voltage, battery powered power supply. So we'll connect our wires up to the bulb, find a safe place to hold it so I don't get zapped, and I'm going to turn it on. There you go. You can see that arc down there, and if I point it at the camera, you should really see it. There you go. Now, I'm not putting much power into this. It's I think it's like 7,000 volts, but I don't know, less than a milliamp, I'm guessing. I've never really measured it. It's nothing fancy. It's just I think it's a taser power supply, actually, that I just have in here with some circuitry to control the battery. But I use this little box sometimes just as kind of a cursory tester to see if there's a short inside a bulb or something like that. It's handy. You know, I have the connector on it, so I can plug it right in if I need to. I don't know if, yeah, of course I don't have one sitting here. Oh wait, yeah, I do. Here we go. Let's see. Oh, no, wrong connector. Well, you get the idea. In fact, let's try it on this one. Right here. This will be cool. Let's see. Negative, positive, and I even have a nice little handle. Well, you could probably hear that. So it's acting a little funny there because, as I said, this is a DC rather than an AC. So the arc tips, the points inside the burner there, are not going to be able to handle an alternating arc that goes back and forth. They want an arc that just goes one direction. So now let's look at this Epson. As I said, this bulb is made by a company called Iwasaki I, also a Japanese company. They do not make aftermarket lamps at all, as far as I know, which I'm sure Epson likes, but I think that if you owned an Epson projector, you should be able to have options. I'm not saying you have to buy aftermarket, obviously I'm a little biased, but you should have options. So this bulb, as I said, made by Kawasaki, has a very interesting feature. The strange wire connections notwithstanding, this has a double reflector. This piece right here represents what they call eTorl technology, E-T-O-R-L. It's a secondary reflector that's on top of the burner. I'll hold this burner in the same position. You can kind of see there's a second reflector that forces the light back down. Supposedly this increases light output by about 20%, and I do believe it. I have compared non-eTorl bulbs to an eTorl bulb, and it's definitely a bit more light. Because the way these burners work, they send light out sideways. It kind of radiates out, because when the spark is going on, there's nothing to push the light forward. It's the reflector's job. So the light goes out sideways, it goes this way, and then here, the pliers will be our reflector. So the light goes out laterally, hits the reflector, and then bounces out. Now, some of the light is going to go that way a little bit and that way a little bit, and that light's not going to bounce out as easily or in a nice direction. So what the eTorl feature does is it adds a second reflector. I'm stalling so I can find something I can pretend is a second reflector. I found something. All right. So the second reflector goes on the top of the arc tube. Oh, let's have this oriented the right way. Like this, so that all of the light that comes out hits this reflector and then is forced down into the main reflector, and then it can go out. It's kind of nice. Works really well. Now, Kawasaki is not the only company to make an eTorl type reflector. Osram actually came out with an aftermarket replacement for Epson that has its own version of eTorl. I'll pop that one out. This way you can see it up close. And I'm just snapping these off. I'm not doing anything fancy to preserve them. I could dig out the ceramic and whatnot, but if you saw the pile I had sitting around it, you wouldn't be too concerned. So here you go. Here's a close-up. You can really see that second reflector. It's actually a piece of glass that's been coated and positioned at the top. Looks like about halfway in between the points. It's pretty cool. Now, let me see if I can find an Osram one to show you. And of course I do. So here's an Osram version of this bulb. Is it? Yeah. There's two. Osram makes two versions for Epson. There's an E50 reflector, which is this one. You can see it's a 170 1.0 E50, so it's 170 watt, 1 millimeter arc gap, and an E50 reflector. On a side note, I have noticed that this says E50 and it's about 50 millimeters wide. So that's why I still think that number has something to do with the reflector side. And the E54 actually had a 54 millimeter reflector. So anyway, I digress. So Osram does it a little differently. I imagine because of production costs, having an official second reflector like that one is probably expensive to make. So what they did was pretty clever in my opinion. They coated the burner to reflect down. It's actually a really well done coating. You can see it goes about the same amount of reflective distance that the Epson would. We'll put them side by side here. And they get virtually the same light output. I've compared OEM, or the Iwasaki bulbs, to the Osram bulbs. In fact, I did that before I gave our company permission to even sell these. And the light output was quite good. It was, in some cases it was equal, in some cases it was a little less, in some cases it was a little more, but it was always within 50 to 100 lux of the other measurement. So yeah, it's not a bad bulb. I have seen issues where Osram has installed these crooked into the reflector, but that's not a burner problem. That's a final assembly problem. So yeah, so this is the eToro system that's used for a lot of Epson units. Not all Epson units though. Some use standard non-eToro lamps. There's a few Epsons out that use Philips bulbs. As far as I know, there are none that use Osram from the factory, but I could be wrong on that. So yeah, that's I think about it for now. I can see my video is well past a half hour now, so I'm gonna make a pile of lamps here for the thing that you're all gonna look at. The can't believe I'm having a cognitive stall here. Thumbnail. Thank you. Yeah, I need a thumbnail picture, so let's make a cool thumbnail picture with a bunch of what I'll call lamp trash. So as usual, if you have any questions, stick them down below. And if you like the video, do the like thing, or dislike if you didn't like it. But aside from that, I hope you sat through the whole thing, and if you did, thank you. And let me know if you have any questions or any of that fun stuff. Thanks for watching.